So in this video, what we're going to talk about is something called the cardiac pacemaker potential, right? Cardiac pacemaker potential. So if we look at this word here, if we look at this phrase, we notice that the second word here is pacemaker, right? So this is really the key of what this event or what this process is. Essentially what we're talking about is we're talking about establishing the heart rate, right? We're talking about establishing the heart rate, right? So what do you think to yourself, what is a normal heart rate? In your mind, what is a normal heart rate? And it may be a range. You could give a specific number, right? So we may say that a normal heart rate is somewhere between 60 and 100 beats per minute, right? So it could be a little bit higher than that, right? So really a higher heart rate, anything above 100 is typically considered tachycardic, right? Meaning an increased heart rate, a fast heart rate. Anything below 60 is typically considered bradycardic or bradycardia, meaning a slower heart rate, right? Now, you can have variation in heart rate and still be normal, right? So my resting heart rate, my personal resting heart rate is usually somewhere around 50, right? So it's a little bit lower than the low end of normal, the lower than the 60, but that's totally normal in my case, right? So we're talking about a typical average range, right? Now, so for this pacemaker potential, the events that we're going to discuss are essentially those events that are setting and establishing that given heart rate, okay? Now, one important thing to note about the pacemaker potential is where it's occurring, right? Where is this pacemaker potential occurring in the heart? So there's two types of cells in the heart. One type of cell is called a contractile cell, right? And these are part of the myocardium, right? So if you know the myocardium of the heart, that thick middle layer of the heart that's contracting, that's the myocardium, right? The myocardium. The second type of cell that we have are called autorhythmic cells, right? Autorhythmic cells. And these autorhythmic cells, think of them as being automatic, right? So think of them as depolarizing and contracting, as we'll see in a little bit, automatically, right? So think automatic, right? So that autorhythmic, that's where we get that term there, right? Autorhythmic. So this pacemaker potential cell is occurring in these autorhythmic cells, and we specifically have these in a region called the SA node, or the sinoatrial node, right? That's where this is occurring. This is kind of in the wall of the right atrium is where these SA nodal cells are located, right? So if we talk about this pacemaker potential, let me come down here and let me draw a simple graph. So we're going to draw something very simply here. And we can plot on this graph, we can plot a few different things, right? So one thing that we can plot is something called the resting potential, okay? The resting potential. And we're going to draw that here in kind of this turquoise color, right? So this is referred to as the resting membrane potential for our cells, right? Now, just above that, we have what's called the threshold, right? The threshold potential, right? So this is the threshold. I'm just going to write TP, threshold potential, okay? This threshold potential is usually somewhere around -40, so we'll say -40 millivolts, and our resting potential is somewhere around -60, right, millivolts. The specific values aren't the most important things in the world, but it's helpful to know just as a reference, right? So what we're going to do, and I'm going to draw this sequence out, and then we're going to talk about it, right? And then I'm going to show you an image below in just a moment. So what we are talking about, and I'm going to draw this sequence of events. So we're going to kind of come up here. We're going to increase in voltage. We're going to come back down, and then we're going to start over again, right? So importantly, and I'm going to make a note here at the very beginning, from this point here, I'm going to draw on this pink line, from this point to this point, that is the equivalent to, or it corresponds to, one heart contraction. So your heart contracts one time in between point 1 and point 2, right? Point 1 and point 2, okay? Now, we'll talk about this in a moment, but start to think about what that means, or what would it mean if we took number 1 and 2 and we spread them out further, okay? What would it also mean if we took 1 and 2 and we pushed them together and they were closer to each other? What would that imply as well, right? So keep that in mind as we as we go throughout this. Okay, so first things first is in this first initial rising phase that we see right here. Right, this is really what's called, if you look in various textbooks, this is what's typically described as the pacemaker potential. This initial kind of rising phase. Right, now in this phase there are channels that are, and I'll write that over here, I, and then they have a little small subscript F. And these are called funny current channels. The I, this stands for current. And the F, you may have guessed it, stands for funny. Stands for funny. So the early scientists who discovered these channels thought that they behaved in a funny way because they actually are permeable to both sodium and potassium. However, they're more permeable to sodium. So they called them funny current channels, right? So in this rising phase here, you have these funny current channels. They're open, but they're more permeable to sodium, right? They're more permeable to sodium. So I'm just going to write here primarily sodium influx. All right, so meaning primarily we have sodium rushing into the cell, okay? Now somewhere around this point here, I'll draw this little line. Those sodium channels, or those funny current channels, are going to close, and then you will have calcium channels begin to open. All right, so in this phase here, we're going to have calcium influx. So meaning calcium is now rushing into the cell. And then same thing in this rising phase here, we also have calcium influx. Right, calcium influx. So this rising phase here, where we have calcium beginning to rush into the cell, you call this the depolarization phase. Okay, so depolarization phase. So we'll write over here. First phase that we have is called depolarization. Right. When you think of the term depolarization, think becoming more positive. Right. We're moving to a more positive value. Right. And if you need to review some of these terms, go back and watch the video on the neuronal action potential, and some of those concepts will be discussed there as well. Right now, next phase that we have is right around this point here. Okay, the calcium channels are going to close, so we'll write calcium channels close, and at the same time we begin to have potassium channels open. Right now, when you're looking at these and you're saying, okay, sodium is coming into the cell, calcium is coming into the cell, potassium is now leaving the cell, right? So we'll say here, during this phase here, potassium is leaving the cell, so we'll say potassium efflux. So potassium is leaving the cell. Think about where you have sodium and potassium relative to the cell. So sodium or potassium, which one do you have primarily inside the cell? Right? Which one do you have primarily inside the cell? You have primarily potassium. Okay. Which one do you have primarily outside the cell? You have primarily sodium. Right. So if